Hi, I'm Mike Culver, a Web Services Evangelist with Amazon Web Services. In the next few minutes, I'm going to show you the basic principles behind Amazon SimpleDB and explain why it makes so much sense. Put simply, Amazon SimpleDB is a database as a web service. There are several important reasons to consider using SimpleDB in your next project. First, and perhaps foremost, you don't have to install and administer a database. That dramatically lowers your cost and hassle factors. Heck, you don't even need a software license. Second, it's a very low-cost way to operate a database. More on that in a moment. Third, if you wanted to replicate this sort of availability on your own, you'd need to cluster at least 3 databases for the same durability. And finally, you can scale from prototype to thousands of requests per second with exactly no effort on your part. It just works. I said that I'd explain cost in more detail. The business side of Amazon SimpleDB is as compelling as the technical side. You only pay for what you use with no sign-up fee or monthly minimum. We charge $1.50 per month for storage, that's per gigabyte, and the same bandwidth fees as for our other services. That is 17 cents per gigabyte for downloads and 10 cents per gigabyte for uploads, with no charge whatsoever for bandwidth between AWS services within the cloud. That 17-cent price is actually tiered, so your cost may be as low as 10 cents per gig at very high monthly volumes. In addition, there's a 14-cent per CPU hour charge for operations on the database. However, it's so inexpensive that as far as I can determine, you could perform something along the lines of 1 million queries for $1. Each operation returns a box usage statistic in order that you can calculate the actual cost, and I've never seen so many zeros in front of the first significant digit. Okay, enough of that. Let's roll up our sleeves and try out Amazon SimpleDB. I downloaded this JavaScript scratchpad from aws.amazon.com and then edited it just a bit in order that my credentials are embedded in the code. Obviously, it wouldn't be too bright to record a webcast where I had to type in my secret key each time. Records live in domains, so I'll choose List Domains from the drop-down list. I'll leave the parameters blank, and then I'll click Invoke Request. Note that each time I click on Invoke Request, the URL changes just slightly. That's because I'm generating a signed URL that's a hash of my secret key with a variety of other parameters, including a timestamp. It's the timestamp that changes the signature each time I click. When I click on the URL, an XML document is returned that contains the name of the one existing domain, as well as box usage. If I multiply the box usage by 14 cents, I'll know the actual cost for this query. In plain English, that particular query was almost free. By the way, I've also modified this tool so that these URLs are clickable. Let's create a new domain. I'll choose Create Domain and then type in zip codes. Clicking on Invoke Request and then on the URL, I can see that the request succeeded. Sure enough, List Domains now returns my new domain. By the way, domain names are case sensitive. Put attributes is the method to insert records. Unlike a traditional relational database, there are no schemas or one-to-many relationships or any of that other overhead. There are only items and attributes, and everything is the same data type. That is, the only data type is a string. There are docs online that describe how to handle date and number comparisons in queries, but I'm not covering that topic here. Let's enter a zip code. Zip codes, plural, is the domain name, of course. I'll start with 98144, which is in Seattle, Washington. Next, we'll add city as an attribute, with Seattle as the value. After that, let's add state and WA, which of course is the abbreviation for Washington. Clicking on the button generates a link in this particular tool, and of course clicking on the link adds the record. Next, I'll add one more in Redmond, Washington, which has a zip code of 98052. So I'll enter the attribute city with a value equal to Redmond, and a second attribute state with a value equals WA. I'll enter a third record in Wisconsin just for variety. Here the zip code is 53705, which means I need to enter the attribute city equals Madison, and the state equals WI for Wisconsin. Queries are especially interesting. We'll start by choosing Query in the drop-down list, and then entering zip codes as the domain name. If I leave everything else blank, you can see that all three entries are returned. Note that only the list of items is returned, though. There's no attributes in the result set. This is by intent. In fact, any long-running query is automatically terminated after 5 seconds in order to ensure that no single query can monopolize the system. And by restricting the returned result set to just a list of items, we are very lean and mean in terms of query execution time. There's really two good ways to return the attributes associated with each item. The first is to loop through the list returned by the query and spawn a separate thread that fetches the attributes associated with each of those items in parallel. That is, if you want the attributes for 100 items, then spawn 100 threads. Performance is amazing. If that programming style doesn't describe you, then Query with Attributes does all the work for you. As you can see, the entire list with attributes is returned in a single call. Finally, let's go back and look at query syntax. I'll enter zip codes as the domain name again, and then request all items in Washington. Note that this is not SQL syntax. Sure enough, just the 2 records in Washington are displayed. I'm not going to chunk through the delete methods because you have the idea by now, so head over to aws.amazon.com and get started. I think you'll find that this is a very compelling value proposition and very easy and lightweight as a method to get started programming against a web service as a database. So, thanks for watching.